Hi, I'm Michael Friedman and I'm team leader.
Hi, I'm Michael Chavez.
Hi, I'm Petros Serbana.
And I'm Kartik Vempati.
Hi, I'm Wessam Aziz.
And we're Team 3!
For our design project, we chose to optimize on the design of the medical walking aid, or crutches. We weren't sure about the features exactly that we needed to improve upon, so we decided to put out a survey on SurveyMonkey. Given that the use of the crutch was mostly a temporary thing, we knew that we couldn't do a feature that will spike up the price of the crutch too high. The survey was taken by about 70 people. 90% of the people said that they are willing to pay for a more comfortable crutch, whereas about 70% of the people said they're willing to pay for a more portable one. We know that comfort came out to be a really subjective matter, and by taking different approaches or different designs, we were possibly limiting our market, as well as the fact that given the scope of the class, comfort would have been the harder issue to address, so we decided to go with the second highest, which is portability.
So after addressing the issue of portability, we wanted to determine our product design specification. Our main concern was to reduce the length of the crutch by up to 50%. We wanted to do so while also maintaining stability for users of up to 300 pounds and from height ranges from 5'1" to 6'7". We wanted our product to be easy to use and to be able to be folded and unfolded within 20 seconds. We wanted also to do all this while maintaining the crutch weight at about a few pounds heavier than the original crutch.
Once we chose portability as our main feature to improve upon on the crutch, we had to evaluate a few different ideas that we had. The first was a retractable tubing system with sliding tubes to reduce the height of the crutch, but unfortunately that would compromise the stability of the crutch, so we had to scratch that one from the pile. The next was a 2-hinge folding system going over and under to reduce the size by about a third, but that ended up being too difficult and having too much structural integrity compromised through 2 different hinges. So we had to go with our last idea, which was cutting the crutch in half and using a lock and bolt system in order to hold the crutch together upon putting it together.
We chose to implement our locking mechanism through a quick release collar shaft through a cam lever. We attached that piece to the bottom half of our crutch, allowing the top piece to go into the collar shaft, locking the whole system together as one piece. We also chose to manufacture the collar shaft out of aluminum due to its low cost, ductility, and lightweight.
In order to machine the shaft collar, we used the UCSB College of Engineering's machine shop's electric discharge machine. We chose to do this because of the open geometry and the round shape of the shaft collar. Because of the complex geometry of the cam lever, we chose to outsource this part to a bike shop in IV and buy it from there.
After the prototype was built, we had to do testing in order to make sure that our results proved fruitful. First, our crutch will extend from a range of 5'1" to 6'7" using 2 different mechanisms. We tested the stability by putting 150 pounds worth of dumbbells across the top in a belt and testing the range from 30 degrees to the norm to the other opposite 30 degrees to the norm to ensure no deformation, and then that it was completely stable. On top of this, we weighed the crutch before and after, and the new attachments only added 0.44 pounds of weight, which is very good considering the original design was only 2 pounds. SolidWorks simulations prove that the crutch can hold 185 pounds without plastically deforming, and a clamp analysis proved that only 8% of the yield stress was achieved, meaning that the clamp could open and reclose without plastically deforming. The crutch itself only takes 10 seconds to fold, as demonstrated here. 2 levers are released, pulled out with a bungee cord, and folded over the top.
The crutch we have at hand today is a mere prototype, and there is a lot of room for improvement. For starters, we can try to implement a more ergonomic cam lever for greater comfort and better aesthetics. We could also use a greatly thinner collared shaft in order to make it easier to snap open and shut, as well as use a different mechanism to weld everything together than epoxy for a greater structural integrity.